students, ladies and gentlemen. It's a pleasure for me to be here today. It's the first time we visit your lovely country and your lovely city, and we certainly appreciate it and like it very much. So it's a pleasure to be here today, also because I really like to share the experiences we have on introducing renewables in the small country where I come from together with you. So thank you so much for inviting me, especially a thank to Professor Omori and to the University of Kyoto. What I will do today is first to tell you a little bit about some energy characteristics from the country where I come from. Then I'll move on to say a little bit about how we have introduced renewables in Denmark. And then finally, I'll tell you something about where we are heading. So let's start. Let's see if it works. Yes, it does. Okay. I come from a very small country, Denmark, as you can see here in the middle up here. We are only 5 million people, so we are much smaller than you are in Japan, and much smaller than Germany as well. And of course, in a European context, we are only a little puzzle in a big puzzle play. So, but nevertheless, I think when we look into renewables and environment, we have done quite much. Actually, Denmark is taking part of a larger Nordic power market, and I just show you this picture because it is a little bit important to understand how we actually have been possible for us to integrate that much renewables as we have. Denmark is shown down here. We are part of a larger Nordic area where we have Norway, Sweden and Finland, and together we are actually one common power market. So when we have no bottlenecks, actually the power price will be the same within this large area. Then we have close connections also to Germany down here. And actually, you can say that we are actually moving into, if not a common power market, then something that will be very close to a common power market for a large area in Northern Europe within the next few years. And of course, part of the reason for that is that we have some strong interconnectors. We have strong interconnections with Norway, with Sweden, with Germany as shown as well. And then these interconnectors are actually, they have that large capacity so we can actually totally cover our total peak in the power system with imported electricity if necessary. At the time being, we are considering another line to Norway. We are actually considering a line to UK, which is situated over here. So as you can see, part of these interconnectors are actually becoming due to that we need to integrate our renewables. But I'll come back to that. So a little bit upon the development of energy in Denmark. This is actually the gross energy consumption developed from the beginning of the 80s, beginning of the 80s until now. And as you can see, we have almost kept a stable gross energy consumption all over the years. Now the dependence on oil has gone a little bit down. We have some natural gas. Coal is gradually being phased out, and we are introducing some more renewables. And at the same time that we have kept this gross energy consumption stable, then we have actually succeeded in increasing our production in industry, our gross domestic product, as shown on this one, by quite a large number actually. Until now, this was only until 2005, but as you can see, we have increased by 80% by here. But until now, it's almost doubled compared to 1980. And at the same time, as mentioned, we actually has kept our gross energy consumption at a stable level. So for that reason, I believe that it has been possible, although we are a small country, it has been possible for us to decouple the energy growth with the economic growth. So economic growth has certainly pursued, and we have kept the energy consumption at a stable level. Now, the four dominant sectors in Denmark, and I think it's almost the same picture everywhere. Of course, we have households, we have trade and services, we have industry, and we have transport. And most of them actually has been quite stable in terms of share of the total gross energy consumption. However, transport has kept on increasing a little bit, and actually it's always the picture that we see. It's difficult to keep transport from growing. If we look into our dependence on oil, then we have actually had quite large resources of oil in the North Sea, just outside Denmark. And until now, we have actually kept a high degree of self-sufficiency. And not only a degree of self-sufficiency, it's actually been possible for us to export both oil and natural gas as well. But these resources are quite fastly once again, is quite fastly declining, as you can see. The oil consumption is going down, natural gas is going down as well, and by the year 2015, we actually expect that we are going to have a net import of oil and natural gas. So that's one of the reasons that we need to look into other possibilities for energy resources. And actually, we've done that for quite a long time. If we look into the three cornerstones of Danish energy policy, then first of all, we have energy conservation. I think we've done pretty well in energy conservation. I think it's actually the same picture we see in Japan. You're doing pretty well in energy conservation as well. Then we have, as a specific Danish feature, actually, a quite high dependence on combined heat and power, where we produce heat and electricity at the same time in our power plants. As you can see, a very high degree of combined heat and power, and most of the heat is actually being utilized in district heating for warming up the houses. More than 80% of the heat that is generated in these power plants are actually used for district heating. And again, I think you have quite a high reliance on combined heat and power in Japan, as we have in Denmark, so I believe it's quite a common feature. The last part is actually our development of renewables. This one shown up here is wind power, and as you can see, we started back in the 80s, and then we've had a quite rapid development of wind power, and now almost 25% of our power consumption in Denmark is based on wind power. Recent years, it has not only been land-based wind turbines, but also offshore wind turbines. And I've actually looked a little more into detail with the development of wind power. It's shown again on this one. And as these 25% we have succeeded in gaining up here, we've been a little bit stable for the last years. Actually, we introduced a new regulation here, and to a certain extent, it halted the development of wind power a little bit. But now we are back on track again. So if we look into the development of wind turbines, then we actually see that they have developed from quite small machines back in the beginning of the 80s. We simply built thousands of these small ones and put them up all over in the country, as shown on these two pictures here. And then we have actually converted it into large 2-3 megawatt turbines that's much smaller, much taller, and produce much more energy than we have seen before. So this is actually the picture of how the turbines have developed from the small ones at the beginning of the 80s to large megawatt machines, which actually are those that's being installed, especially offshore by now. So what has happened with this upscaling of turbines? Of course, one of the issues has been that it's driven down the cost of the turbines. And actually what we have seen is that now the large 5 megawatt machine is there. It has a rotor diameter of up to 120 meters. Now we are certainly looking into some structures. Now it is advanced machines. It's not the same as when we at the beginning of the 80s developed the small machines around the corner at the blacksmiths. Now they are advanced and certainly produced at highly technical manufacturing machineries. Weight is an important issue. Now we're trying to keep down the weight using new different materials, carbon fibers and so on. And the question is, how far can we actually go in this upscaling? How far can we go in trying to push down the cost of wind power? And I've actually spoken to the experts at my lab, and they say that, well, in 5 years' time we will have the large 10 megawatt machines, and they will have a rotor diameter of up to 160 meters. But we will probably not stop there. In 2025, in 12, 13 years from now, we will see perhaps even larger machines, 20 megawatt machines with a rotor diameter of up to 220 meters. Compared to these, the Airbus 380 that I was using when I flew out here, it's actually a very small machine compared to these large structures of wind turbines. Most of them will be used offshore, but of course part of them will be used on land as well. And actually on land we might see that the infrastructure might actually be a constraining factor. It might be difficult to get different kind of lorries and so on to transport the machines out to where they're going to be set up, unless they are smaller in size than the big ones shown up here. Now, have we done that without any technical problems? Well, I've made this slide, which is actually taken from the western part of Denmark, and it's back from January 2007. But actually, it could just have well been from the winter months this year. And I've taken the total wind power production, as you can see up here, subdivided by power consumption in the area. And it means that when we have more than 100%, then we actually produce more power with the wind turbines than we can utilize ourselves in this area. So we have to export it. So it means actually that up here, over here, we force an export to Germany and to Norway in these cases. Until now, I must admit that we have done that without having any technical problems. But of course, it has some problems, you might say, and especially in relation to the marketplace. If we look at this month, actually we achieved approximately 44% of all power consumption in Western Denmark. It was covered by wind power. And for total Denmark, we actually had an average of 36%. So it's quite impressive figures, actually. And as mentioned, these are actually what we see in the winter months in Denmark also today. Now, moving on to the market power issues, let's just have a look. Down here again is shown a picture where I have the capacity of wind power. This is for December 2010. This is almost at the peak. And if you look at the consequences for the prices at the markets, it's shown at the upper level up here. The black one is actually for the total market, together with the Nordic countries and so on. So this is the total market price, shown in black. And as you can see, there are some variations. But most variations we find from the Denmark West area, where we have all these wind power installed. Then when we have the peaks of wind power, very large production of wind power, then you can see the price is actually going down, shown here as shown over here as well. And actually a market feature is that by now it's possible to have negative prices at the market. So when we have too much power in the system, then actually the price can turn negative. And it means that all those generating power, it might be a conventional power plant, it might be a wind turbine, they are actually losing money if they produce at that time. So for that reason, of course, this is a signal. It's a signal to the producers saying, shut off your power, we don't need it by now. And to a certain extent, of course, it's also what is happening. But as you can see, not always. However, these negative prices are very seldom. And of course, we want the system to react on these negative prices. That's actually what should be happening. Now, let's move to the way we actually have managed to integrate this different kind of renewables and how we have put up our support schemes in Denmark. Actually, I have 4 requirements to the support scheme. The first one is that it should promote the effective development of renewables. We should have a strong promotion of renewables, a strong development of these renewables. The second one is that it should be attractive to entrepreneurs and developers, because there's not so much competition with it in this area. And for that reason, it's very important that we get a low risk so we can attract as many possible investors as possible. And at the same time, this low risk will imply the lowest cost for society at large. My third requirement is that one thing is that it should be attractive to investors. It means a fairly high feed-in tariff, for instance. At the other side, the support scheme should make it possible to drive down the cost of new renewable technologies. I think this is immensely important because at the end, of course, if renewables are going to play a large role in our system, then they should be competitive to other kinds of plants. To introduce renewables is not as playing in a kindergarten. We cannot go on supporting all the time. At some point, they should grow up, and they should actually be possible to make them compete with conventional technologies. So for that reason, it is very important that the support scheme can drive down the cost of the new renewables, sliding down the learning curve, as you probably know it. My third requirement is that it should facilitate this transition to full commerciality. Again, as mentioned, renewables should not be a kindergarten. We should end up with using these renewable sources in exactly the same way as we use conventional conventional plants today. So how have we introduced it? Well, actually, we have used these 4 phases of market penetration. And I think I know it quite well because I believe it's invented by me, actually. So first of all, we have the pioneering phase. Then we have the introduction phase, the market phase, and the full commercial phase. We have time out down here, and this could easily be up to several decades, 1, 2, 3 decades, actually. And then we have the technological risk, as shown here. We have the cost, as shown here. And we have the total deployment of the renewables, as shown up here. And finally, we have to compare it to the price of conventional energy. And of course, if we look into the first phase, the pioneering phase, then it is characterized by quite high cost. It is characterized by quite high technological risk. And of course, these technological risks, it's immensely important that they have come down before we really have the takeoff for the deployment of the renewable sources. And it means that the first phase here, it should be subsidies, it should be grants, perhaps some kind of a feed-in tariff at quite a high level, as we have seen it in most markets until now. Now, if we move on to the second phase, then there's much more takeoff. Now we really, renewables really start to get important. The cost has come down, the technological risks are much lower, and for that reason we can actually start a deployment at a more rapid pace. So feed-in tariffs, as you saw from Germany, for instance, and what we have seen in Denmark as well, is a very appropriate measure of a support scheme of introducing at this level. But at the same time, we should be aware that it is a balance between the level of the feed-in tariff. The higher the feed-in tariff, the better, the more attractive it will be for investors. But at the same time, the more costly it will be for the consumers. So, and we should take very much care that this does not get too costly for consumers. And for that reason, it's important to do some benchmarking and gradually adjust your feed-in tariff to a lower level when it's appropriate. At the third phase, and now it really starts to get, the renewable really start to get going. Now we are in a rapid development, and at that time, of course, we should use some kind of a differentiated feed-in tariff for the first part of it. But at the same time, it is important that this technology gets closer to the market and that it gets compatible with the market principles. And for that reason, I suggest that actually some kind of spot price plus premium is actually being used in this phase, because it means actually that the investors will gradually take over more of the risk that you see at the marketplace. Now, the fourth and last phase, of course, is when we move totally into commerciality. And it's not so much to be said about that. Now we have reached our goal, actually. So let's just touch a little bit upon the reasons why we see that in Denmark the introduction of wind power and renewables in general has been a success story. We have had much employment, much industrial development just seen because we have introduced renewables. And actually there's a number of reasons. Looking into wind power, we have fine wind conditions, but actually they're not the best in Europe. Other countries, as UK for instance, has much better conditions than we have. So this is just a prerequisite, but it's not sufficient. Right from the start, we got a very strong and positive involvement from the government. And I believe that was really important because from the investor viewpoint, it is important that they can believe in that when we set a feed-in tariff, then it will actually going to continue the lifetime through for the technology in view. Moreover, it's important to have the right manufacturing background. We have done much within mechanical engineering in Denmark. I think it's actually the same background you have in Japan, so it's not a drawback for you neither. We have a very pioneering spirit. Actually, we have had wind power for a long time, and it might be one of the reasons that actually we have had a strong public acceptance in Denmark. So almost all over the country, we have seen that people believe that wind power is the right way to go, and not very much opposition. And finally, we've had a good deal of luck, and the last part should actually be mentioned as well, because it is important now and then. Now, just a few pictures from some of our offshore development. The Horns Reef was one of the largest offshore developments that we made. As you can see, large vessels being used offshore for putting up the turbines. and actually the turbines are going to be kept in operation, and repair is going to be done by the use of helicopters. Concerning the offshore development, we have in Denmark made a quite extensive plan on looking at the Danish waters, because of course there are different interests in the waters around us, just as you probably have in the waters around Japan. The interest of fishing, interest of using it for leisure, interest for different environmental protections and so on. So we have made a comprehensive plan for all the areas around us and pointed out a number of areas where we could put up new offshore wind farms. And these dots actually show where we plan to put up new offshore wind farms. A large one is going to be put up here, a 400 megawatt one, actually decided by Parliament. We have quite a number out here. So, normally we use a tendering scheme. So it means that when the government has decided that we're going to put up a new wind farm, then it's actually put out into bidding for the competitors. So it means we tell them where to put up the wind farm. We tell them how large the wind farm should be. There's made a pre-screening of the environmental areas around it. But at the end, of course, they have to decide what kind of wind turbines are going to be used, what will be the cost, and actually the one with the lowest cost in the bidding procedure will actually be the one that wins the tendering process. And I think we have been quite successful in doing that in Denmark. So we have identified 33 sites as shown up here of 200 megawatts, and we're going to utilize most of them. In total, 4,600 megawatts is planned by now, and it's equivalent to 8% of our total energy demand, or approximately 50% of electricity demand. So that was most of what we have been doing until now. And just a few words on where we are heading, and I will not take that long time actually. So for a couple of years ago, the Danish government sent up the Danish Commission on Climate Change Policy, and it was actually our former vice president that actually decided to set it up. And I happen to be a member of that commission, so in general I like the conclusions quite much. And one of our major conclusions was that it is possible to make Denmark independent of fossil fuels, actually by the year 2050. But it will require a total conversion of the Danish energy system. And moreover, could be said that we can do it without excessive cost to the consumers. But I'll come a little bit back to that. So the background, of course, is that we have seen oil prices simply staggering. This was just before the crisis, financial crisis. Then it went down, as you all know, and now we're almost up at the same level again. And of course, it's mainly driven by the world growth, economic growth. As you can see, a very close reliance between the dip in the world GDP and the dip in oil prices. So suddenly, in Europe, we are not doing that well, but I think that Japan is coming up again and the rest of the world as well. But hopefully we will in Europe within that long time also. And what we need to do, according to the Climate Commission, is that we need to increase the level of renewables from approximately 25% to 100% by the year 2050. And at the same time, we will decrease the greenhouse gases by almost 75%. And actually, the picture is that we need to go from approximately 3/4 of our energy supply covered by fossil fuels to a situation where we are totally dependent only on renewables. Wind power will take a very large share, biomass will take a very large share, heat pumps, solar heating, etc. will also take a large share. And what we will see of the major trends is mostly that in the future the energy system will be very much more dominated by electricity than we see today. Most of the new technologies will be electricity producing. So that will be a very dominant change compared to today. Of course, the intermittent sources, solar, wind power, and so on, will have a much larger role to play. And actually, the wind power capacity that we have in Denmark will have to be 6-doubled. We have approximately 3,500 megawatt today, and according to the plan, we're going to have 18,000 megawatt at least by 2050. And barrier might be the resource of biomass, because when the wind is not blowing, of course, we will need something else as backup in the system. We have our neighboring countries, Norway, Sweden, and so on, but nevertheless, we cannot make sure that their hydropower can always help us. So we will need a kind of biomass backup. And finally, we will see radical changes in the transport system. And it might be electrical cars, for instance, but we don't know that by now. And actually, this plan from the Climate Commission was taken up very seriously in the Danish government. So they made their own plan. And actually, this plan was just passed through Parliament not more than 3 weeks ago, and 95% of the Danish Parliament actually voted for the new energy plan. So it just says that not only Parliament, but the Danish society is really ready to go for this radical change in the energy system in the future. And how does it look, the government energy plan? Well, first of all, we need to go from the fossil fuels out here to the renewables as shown over here in 2050. And actually, we have 4 steps in the plan. And by 2020, it's just 8 years from now, then we have to have that 50% of the Danish power consumption should be supplied entirely by wind power. Today we have 25%, so only 8 years we have to double this share of wind power. It's certainly a challenge, but at the same time the Danish TSO, transmission system operator, tells us that it is possible. The next step is actually by 2030 there will be used no coal in the Danish power plants, and there will be no oil furnaces. As you saw on some of my figures before, we had quite a reliance on coal still, but nevertheless it will be totally phased out and everything will be on renewables. And by 35, all heat and power is supplied by renewables. So what is lacking in 2035 is only the transport areas, and that will actually be taken care of in the last 15 years. So by 2050, the entire Danish energy consumption will be supplied by renewables. So I think we are a little bit more ambitious than you saw for Germany. So although they are very ambitious in Germany, we are a little bit in front in Denmark, and we are happy to be that actually. So, but it is an ambitious schedule, and at the same time, it could be said that, well, the Danish government, the Danish population, the Danish country as such, society at large is behind it. And of course, it will cost a little bit more. But the scheduled cost, estimated cost by 2050 says that it can be done for something like 100 euros per family per year in 2050. And it should be within reach, actually, to do so. And that will actually end my presentation. Thank you very much for your attention.